TV time. I'm your host, Clint Doblock. I have decided to have Paul Lorenz back, which is cool. Oh, looks like Ken has decided to slip in as well. Let's bring Ken into the stage here.
Hey
Hello,
guys.
Ken.
Hi.
Today's ZDTV. I didn't. So we've been traveling. We've been out meeting some sales guys in Charlotte, North Carolina. Meeting Ken in person, which is great. I mean, I've met Ken before, but seeing Ken in person. So we had a nice sales kickoff event. Quite a few people in the NetFounder team were there. Did lots of talking. Did lots of eating. Learned some good stuff. Had some guest speakers. And we have another guest speaker today on ZDTV. We're bringing Paul back. So let's bring Paul onto the stage here. Say hi, Paul.
Hello.
Hey,
Good to be
there's
back.
Paul. Good. Yeah, nice to have you back. So we're live on ZDTV today. I don't have, because of that sales kickoff, I didn't make my customary little presentation slide, but I also don't think we've had a release of ZD in a couple weeks now. I know I'm waiting for it because there's a particular bug that I want to see fixed. So I'm ready for the next release. So with no release notes to read. And last week we talked to Andrew Martinez, which was cool. So we've had two guest speakers in a row. That's pretty neat. I don't know if we've ever had back-to-back guest speakers yet. And today we're going to finish off on services. And I was telling Paul before, I don't even remember where we were when it comes to services. So why don't I guess maybe probably a good time for you to kick us off and let us know where we were, Paul.
Okay. So last time we were talking about hosting services specifically, how all the different ways you can host a service and configure those configure services in various ways. And we had kind of gotten through like general overview of services and policies and identities and a few different ways to sort of do basic hosting. So SDK based hosting and router embedded tunneler hosting. So today we're going to kind of dive into some more either complicated and or realistic scenarios and see how far we get. There's a kind of a lot of stuff to still go through, so we'll see if we get through it all.
Okay.
So I thought we would start with just kind of a refresher of where we were in terms of like what we were testing with, right? So we were using a very simple echo service. So the base case was you want to be able to send stuff to the echo service and have it come back to you. So this is kind of like a Z-defined version of Netcat, right, where you can stream data to it and it will just echo it back. So I've got a controller running and a couple of edge routers. So we can take a look at what we've got currently running in the system. We've got a couple of edge routers.
Oh, hang on. You use some shortcuts there. It's my turn to interject. LS is now short for list.
Yeah, so there's some aliases in there, right? So you can.
Oh my goodness! I need to start using LS. I type list far too many times in my life.
Just little convenience things, right? And then
right.
Just like you can do. There's some shortcuts for like you can do list edge routers, or you can do LSERs, right? So.
Yeah, I much prefer that. I just wanted to take a moment because if you're watching ZDTV and you've never I usually spell it all out just because that is the official subcommand, right? And if you're watching from Discourse or whatever, I will use the full blown list edge routers. I won't use the shortcuts. However, personally, I'll probably use LSERs. I knew about ERs, but not LS. So anyway, thanks, Paul. Thanks for that diversion.
Sure. So we've also got some identities in here. So we've got our two edge routers running, and they're both set up to host services. So we have they're set up in tunneler mode. So each edge router also has a automatically created identity that goes with it that we use for putting that router into policies so that it knows which services it has access to, that kind of stuff. And then we've also got a couple of other identities, one called Zcat. So that's our client, where that's our Zdified netcat that you type stuff in, it sends it over the wire, and it reads stuff back out and puts it out to the screen or wherever you're piping it to. And we've also got a single host identity. So, up here, and so this I set up with the ZD demo setup echo single SDK hosted command. Right. So what that does is it cleans up anything from any previous, because we have a few different examples here, right? So this tries to make sure that the other examples don't interfere with this example by cleaning up the service and cleaning up the policies and cleaning up the identities. So we kind of started from a blank slate. It creates the service. So we got our Echo service here. It creates an Echo host 1 identity for hosting the service and enrolls it. And then it sets up the policies. So it sets up the bind service so that the Echo host 1 identity can host the service, and sets up the edge router policy so that anyone who's got the Echo attribute can use all the edge routers, and it makes sure that the Echo service is also set up to use all the edge routers. So now we can run the SDK hosted Echo service like this, and we can access it like this. So if we run this, and we see a thing pop up over here, letting know that we got a new connection, we can start typing stuff here. We see that we got some data over here, read 6 bytes, wrote the 6 bytes back, and then we see them pop back up over here. And so this is kind of our baseline setup, right? And just a quick refresher on terminators. Okay, if this is not running, so we take a look at our services. We've got our Echo service, and then we look at the terminators. You don't have any terminators right now, right? So the terminator defines for a particular service, you can have 0 or more terminators, and they are ways to get to whatever application is actually hosting the service, right? So if we restart our Echo server here, our SDK hosted Echo server, and then rerun this list terminators, we can see that we now have 2 terminators. And that's because when this Echo server starts up, it will connect to multiple edge routers, if there are multiple edge routers available, so that you've got redundancy in terms of how you can get to that service, right? So in this case, we've got our edge router 1 and edge router 2 running. So our Echo server will connect to both of those, create a terminator on each one.
If there were 10 edge routers, would you get 10 terminators?
You would get by default 3, but you can configure that in your application. You can say, I want to connect to at most this many, and it will try to make that many connections. And over time, it will also, it's periodically refreshing its session with the controller. And as part of that, it gets back a list of what edge routers are available to it. So if you configured it for 5 edge routers so that you can get to it via 5 different edge routers, and there's only 2 available, it'll connect to those 2. If one of those edge routers goes down, it'll obviously go back down to 1. If the edge router comes back up, it'll reconnect to it. And then if more edge routers come available, it will try to connect to those until it's got all 5 connected.
Do we have I want to ensure I connect to at least some many edge routers, or is it at most?
It's at most. I think the idea is generally that you could probably implement that yourself by seeing how many connections you have, but in general, right, you want to make sure you're connected somewhere, right? If you don't connect at all, if you don't connect to any, you can tell it, when I try to host a service, if I connect to 0 edge routers within this time frame, then bail out and let me know. Otherwise, if it connects to at least 1, it will, use that one, and then it'll use more as they become available. Um, and it will also, if that edge router, if it only has one connection that goes down to zero, it will also at some point fail out and say, I can't, I can't maintain this because I don't have anything to connect to anymore. The minimum is interesting. I'm not sure. I mean, usually that's kind of the boundary case, right? You definitely want at least one. I think if you want to, sort of from a management perspective, if you want to be able to see if your services are healthy, we have events in the system that are generated as routers go online and offline, and as terminators are created and destroyed. So when a terminator is created, that generates an event for that service, and so you can follow that stream of events and say, okay, this service is now being hosted, has one terminator, so it's being hosted by via one path, and you can set up your own alerting to say, this thing went from 3 to 1. We know that we want at least 2, so generate an event to investigate and see what's going on there. So from the application perspective, it's not there, but from the monitoring perspective, it's there, which is, I think, probably the more important piece. Okay, and then just to kind of talk about some of these bits a little bit, just kind of refresh ourselves again. So we have our 2 terminators because we have 2 ways to get to this application. And we have our cost, which is used when making routing decisions, right? So you can update the cost if you want to favor one over the other one. And you can also change the precedence. So there are 3 precedences. There's required, default, and failed. And usually you would use required if you are in an HA setup and you want to always use a specific service and only fall back to another one if that one fails. So in that case, you'd have one terminator or one set of terminators that required that are all going to the same application. That's your primary. And then you'd have one or more terminators that are going to your fallback, which would be at default. And then if your primary ever died, and those terminators would then get set down to failed. We'll talk about how that happens shortly. And then the default would take precedence over the failed, and you would start using your secondary until your primary came back online, and then it would go back to required. And then the dynamic cost is, these are things that change as services get used or as we have failures or successes, as you're using the service. So if you try to use a particular terminator, it fails, the dynamic cost will go up, and then over time will come back down. As more circuits are created on a particular terminator, the cost will go up, and as the circuits get removed, the cost goes back down. Do you hear a lot of noise in the background? Is it?
There's a fair amount of cappuccino making going on. Yes.
That would be my guess.
Should I go?
We can understand you just fine.
It's okay. It's okay. Yeah. Don't let it stop you.
So to recap real quick, there's cost, dynamic cost, and precedence. And cost is absolute cost. Dynamic cost is based on observations or metrics, so it's adaptive. Is that right?
Yeah. So there's a kind of a static cost that the end user configures, right? And that can be based on, maybe something is hosted on a particular instance that's more expensive. Maybe using some dynamic compute that is maybe more expensive. You would cost that up all the time. The dynamic cost is adjusted by ZD itself over time as it sees usage go up and down, or as it sees failures and successes happen on that particular terminator.
Got it. And the precedence, you said default and required. Is required the default, or what were the other possible settings for precedence?
So there's required, default, and failed.
Required, default, failed. Okay. Is either required or failed a default, or is default yet another possibility?
Default is the default. So there's three precedence levels. The default is default, and then required is a higher precedence than default, and failed is a lower precedence than default.
Okay. I just haven't quite grokked the purpose of the precedence yet, but you were explaining.
Right. So usually there's two basic kinds of setups where you have multiple servers that you have hosting the same service, right? And those are sort of failover scenarios and scale scenarios, right? So in a failover scenario, you would have a server that you always want to use, and that one would be set at required. And then if it failed, you would want to follow over to your backup, right? So maybe let's take a look at that. So rather than sort of talk about, let's show it. So
Sure.
we're gonna move from a single host to two hosts here. So let's set that up. So we got our we're gonna stick with SDK hosted for now. So basically the same setup that we had before, except now instead of a single application, we have a single identity. We have two identities, right? So we're gonna restart this one. Now we're also gonna start a second one. So if we look at our terminators now, we should now have 4, right? So each of these is connected to both of the edge routers. And if we use our service, you can see it's connecting to this one. I'm not sure if it'll we might have to run a couple. Here, you can see that it's kind of load balancing across the two. And
Okay, so on the right, you've got two different instances of Echo Server with discrete identities that it looks like you ran with a new demo subcommand in the ZDCLI. That's cool. So I guess that lets you store a configuration and just assign an identity to that server. And so then when you send with Zcat, you send a string across, and we're seeing it sort of load balance between the two servers.
Yeah, so we're running Zcat twice. We're running it once here and once here. So we'll see, this one is sending to this one.
That went to 2.
This one is, yeah. And this one is sending to 1. And we can see, if we look at the terminators, we can see that these terminators have an increased cost here, right? So because these are the two that are being used, so one of these must be for this one and this one, well, the other one's for this one. So they both have a slightly updated dynamic cost because they each have one circuit running across them.
Okay.
So these all currently have a default precedence. But if we wanted to, view this as maybe as an HA type of setup, where maybe say you've got a common setup would be like a database, right? So you've got your primary database that you want to use. If that database goes down, you want to fail over to a different one, but you generally always want to go to the same place unless that instance has gone down.
Gotcha. Yeah. Okay. That makes sense. So it's like a primary secondary relationship that you're expressing with precedence.
Yeah. So let's take one of these and let's pretend that one is going to be a primary. So let's kill our clients here. And what I did is I added some agent, some IPC agent software in there so that I could send signals to our SDK applications and tell them to change their precedence and cost, right? Because via the SDK, when you establish a connection, you can tell it how you want to host. You can say, I want to be the primary, or I want to be the backup by saying that you're the required one, or by saying you're at default. And you can also adjust your cost, and you can do that either maybe because that's configured ahead of time, right? You could say, my config file tells me that I'm on an expensive service, so I'm going to set my cost up higher. Or you can do that based on dynamic characteristics, right? Maybe you look at your internal queues, and you see your queues backing up. Maybe you increase your costs so that you get used less often, right? So we're going to do that kind of at runtime here. We're going to do agent echo server update terminator, and we're going to find the PID of one of our Zcat or echo server instances here, and we're going to set our precedence to required. And while we're at it, we're going to set our cost to 100. But we can see that this one here says that it updated its precedence required and its cost 100, and did that by sending messages to the edge router that's connected to, which then forwarded up to the controller. And if we look at our terminators, we'll see that these two terminators now have cost 100 and precedence required. So if we use Zcat again here, it should always go to the same place.
Right.
Right. No matter how many
required.
Yes. And then if we were to kill this one, and looked at our terminators again, now we're back down to 2. That one's at default again. So now when we use our service, it's going to go to the backup one. If we restart this one, it'll start back up again. There'll be 2 terminators again. Now, because we did this at runtime, right, this will come back at default. But presumably if this was your primary, you'd have it set up so that when it connects, would be setting its precedence to required.
So if you have 3 and 2 of them are required and 1 is default, then does it just move the load balancing algorithm up to the first tier?
Yep, so it'll always load balance across the highest precedence level that's available. Okay. So, if you've got 5 required, it'll balance across those 5. If you've got 1 at required and 2 at default, it'll always use the one that's required, which also means that if you have any that are at failed, it won't use them unless all your terminators are failed, in which case it doesn't really matter. You might as well try to see if you can use one of them. So it will then load balance across your failed terminators. So let me see. So
computed cost that is a function of the static cost and dynamic cost that is evaluated after precedence.
Yes, right, exactly. So it uses, if you had, 2 at default, and one of them had a cost of 100 and one of them had a cost of 0, it would pile your circuits onto the one that was lower cost until the point where the dynamic cost got high enough that it kind of outweighed the static cost, and then it would start load balancing them across both at that point. So yeah, the sort of the full cost of a terminator is the static cost plus the dynamic cost. And they're
simple addition then.
Yeah, and there's this, I think we talked about this to some extent last time, but there's other things that go into that, right? So like, as it looks across the whole path, it also looks at link cost and router cost, and so all those things get added up into one final cost that gets used to determine, which of these things is the right one to go to. Although, required always wins over anything that's default.
Yep. And the dynamic cost is not tunable in this case. If I wanted to adjust the cost, my tunable is the static cost value.
Right? Exactly, yeah.
So I can just use that as an arbitrary way of assigning a higher or lower cost overall to a particular terminator.
Yeah, and you can do that externally, or you can do it, if you have an SDK hosted application, you can do it via the application can update its own costs dynamically as it's running. If that's something that you want to do. So this is kind of like there's actually a third scenario here. So we've covered 2 scenarios. One is the HA scenario where you've got a primary and a secondary. You want to fail over. If you're not setting precedents, then it's just sort of straight up horizontal scale, right? You might want to run, if you got a web server or something like that, you might want to run 10 or 15 of them. They'll all be at the same precedence, and we'll just load balance across those. If one of them goes down, those terminators go away. The load balances over the ones that are left.
So sadly, we do have a chat question. However, Restream didn't show me the question in time. It was from a few minutes ago, asking from Marcos. Let's show it. Boom. Was any special parameter to have that in the services configuration, or is it automatically assigned the configuration when we select two routers as a bind policy? I don't remember what that might be about right now because it's a bit out of context. So maybe you do, Paul, and if not, we'll ask Marcos to remind us. Apologies, Marcos.
Yes. So I mean, yeah, I think maybe the question was around like who's allowed to host a service, like what you have to do anything special to allow multiple applications to host a service for either HA or H horizontal scale. And there it's really just from a policy perspective, if you've got permission to host, then you can host. And if you want to limit that to one thing, then you just have to make sure that you only give one identity that access to that service via policies. So hopefully that answered that. If not, maybe Marcus can clarify and we can go back to it.
I have a little bit of a novice question about terminators. I'm not remembering whether terminators are always created, are ever created automatically.
So
certainly,
in our examples here, they're pretty much all being created automatically, right?
Okay.
So when the SDK,
do you consider it automatically if the code programmatically instructs the ZD to do it?
So the reason
Right.
the reason the question was raised for me is that we're adjusting the properties of a terminator, but I thought that like in my practical experience, of course, mostly going through like NetFoundry free tier, they just magically get created. So I'm not accustomed to adjusting the properties on them, and I thought if they're ephemeral, then are my properties changes going to be lost if another one is created, or is there some higher abstraction where I can make these changes so they can be applied as a part of a policy?
So yeah, so from our current perspective of an SDK hosting application, we can control our terminator programmatically from our application. So there, it's kind of up to us to say, I'm hosting this application. I know that I'm the primer, so I'm going to set my when I host, I'm going to set my precedence to this, right? So it's not, it is ephemeral, but because you're the one doing it every time, you can set it up the same way every time, if that makes sense.
So are there two types of terminators, some that are sticky and some that are ephemeral?
So you can also create, these are sort of dynamic terminators, right? They're created as the application connects. It's created. You can also create terminators for router terminated things. We tend not to use those as much these days because you kind of lose a lot when you do that. So the next thing we're going to go into is router hosted via tunneler, router embedded tunneler hosting. So where you've got a tunneler that's living in the context of a router and is hosting services, and that's kind of similar to router terminated. Basically, where you're telling it this router is just going to reach out and connect to the service here. What you don't get with that is you don't get things like health checks. So you can do it, but you don't get the advantages of using the tunneler app or the tunneler functionality, which will do things like the health checks for you, and can also.
And the two services you have here are SDK services, and now you're talking about the next chapter here is to move to identities that are the router tunneler identity.
Yeah. Yep.
But the same algorithms can apply to both?
Yes.
Okay.
From the controller perspective, all it sees is terminators, and it has its metadata around the terminators. Then it knows how to use that, but it doesn't particularly care whether that was created by an SDK hosted application, or it was created statically, or it was created by a tunneler or a router embedded tunneler.
And the same question did also come in from Marcos too, around when they're created. So I think we've covered Terminator creation pretty well.
Yeah, and just to clarify too, a little bit is that the SDK doesn't explicitly create the terminator. It just tells the edge router, "Hey, I want to host this service." The edge router is responsible for making sure that you're allowed to host the service, and it then creates the terminator on the SDK's behalf. So I did want to cover one other thing that we kind of covered at the very tail end of the last session, which was there's a third reason why you might want to have multiple things hosting the service. So right, there's the failover scenario, there's scaling out your application scenario, and then there's the scenario where you have things that kind of all look the same, but are also unique. So this is where maybe you want to host, have an SSH service, and you want to be able to configure that thing as SSH and be able to say, this user has access to SSH, and not have to create an SSH, a specific or a different SSH service for each SSH host that you have, right? So in that case, you're creating a service to kind of cover a whole spectrum of things, but you have individuals within that. So SSH is one of the main examples that we tend to use. The other one is something like a VoIP service, right? Where you, the things that are hosting the VoIP service are like individual users or phones or VoIP applications. But you can't, when you want to get to an SSH host, you don't want to just say connect to SSH and then you end up on some host somewhere. You want to be able to say, get me to the SSH host that is on, if you're using like Greek gods, on Phobos or Mars or Deimos or something, like you want to be able to pick it. If you're using a VoIP application, you want to be able to dial a specific person, right, that is hosting this. So let me show how that works from a ZD perspective. So our Echo server has another flag, which is you can run it as addressable. And that lets our particular SSH or our particular Echo instance be reached by identity. So if you look at our terminators now, I'll make this a little bit bigger. We'll see that the terminators now have an identity associated with them, right? So we still have a terminator for each one of these on each edge router. So there's 2 for Echo host 1 and 2 for Echo host 2. But now there's something associated with them that lets us reach that one specifically. So if we were to run our Zcat again, it would actually fail because we didn't tell it which one we wanted to reach, right? Like with a VoIP application or an SSH application, you don't want to be able to say, hey, connect to SSH, and then it just picks a random one, right? That would be pretty dangerous. Or if you wanted to call somebody and you said, hey, call VoIP, and it just picked a random user, right? That might be a fun party game, but not particularly useful, right?
Right.
You don't want to play chat roulette when you're trying to reach somebody. So what we have to do now is we have to tell it which one we want to get to. So this is just syntax that's specific to our little Zcat application. It doesn't. It's not. You can do this however is appropriate for your particular client application. But here we're just going to give it a name. So we're going to say Echo host 1 at Echo. So we're giving it the identity we want to connect to at the service we want to reach. Now, see it pop up here. We say hello. We can see this happening up here. If we want to reach the other one, we do Echo host 2, and now we see it pop down here. Right. So we can pick. And again, what it will do is because we have 2 terminators for each one, it will load balance across those 2. So you can still get high availability from a router perspective to make sure that you're not limiting access to your service via a particular router. So if a router goes down, as long as you've got multiple routers available to you, your VoIP application will still work, your SSH application still work. Obviously, if you're the host that you're SSHing to goes down, there's nothing you can do about that. But at least we're getting HA where we can, right? We're limiting the number of single points of failure in our system.
So when you added the addressable option to the SDK server, the Echo server, that changed what it asked from its edge router. Instead
Right.
of
So when
asking it to host the service, it also said, I have only I want to host it, but only send it to me if addressed to me directly.
yeah, it really just sends it its identity that it wants to be bound as. So if you don't specify your identity, then your identity is blank. And when you connect, by default, if you don't specify identity to connect to, your identity is blank, right? So in a sense, you are connecting by identity, but everybody's identity is blank, and you're connecting to a blank identity, so you get to pick from all of them, right? So it just kind of it's not really special case behavior. It's just that if you don't pick an identity, then they're all the same, they're all blank, and when you dial, if you don't pick, they're all blank, right? So
it's a way of
still match up.
expressing to the system that this instance of the application is stateful or unique. It's different from all the others. It's not interchangeable with all the others.
Right. It's kind of in a way, you can kind of give it as like a Terminator group.
It can still be the same as the others. It just allows you to specifically address the one that you're specifically looking to address.
Right. You could have two applications. Go ahead.
Yeah, I was going to ask, maybe you're going in the same direction here, but I was wondering if you could have HA addressability. Like, what if you did the wrong thing when it comes to ZD, and you chose to have two different virtual machines, and you shared the identity between them, both of which bound as the identity? Would you then rob Robin? If you SSH'd to whatever the identity is, would you go to each of them, or would that actually be an error in the system?
It depends. If you are actually sharing the identity that's hosting, then the system can't really tell you apart. It does.
But they would have their
facility.
own terminators. They'd have discrete terminators. But if you were trying to address to the identity, then it would not be able to disambiguate.
Right. So we do have a facility for trying to prevent things from binding as something that they're not, right? So if you can also provide a secret when you bind, and that would be based, by default, it will use your, when you generate a ZD identity, you get a cert and a key with it, right? So it will use that to sign something, to create like a MAC, and it will push that up. And then once somebody has claimed an identity, if somebody comes in and wants to be the same identity, it's got to have the same, be signed by the same person, which just means that somebody could potentially hijack a different person's identity, but then when that person tried to connect, it would tell them that they couldn't because somebody else had got it, and then they would know that something was going on, as opposed to silently, maybe if it was a VoIP application, maybe silently load balancing that person's calls across two different systems, you would know pretty quickly that there was something going on.
Yeah.
And that piece is also pluggable. So depending upon how strict you want to be with your enforcement and how you want to enforce those things, you can, write your own code to say, here's how I'm going to verify that this person is allowed to claim this Terminator identity. That piece will probably continue to evolve as we do more with VoIP. We'll probably look into that, evolve that piece more to make sure that we're kind of covering our bases there.
Right. So what I'm hearing is that today it would silently succeed. It wouldn't be an error unless you were actually trying to address a connection to a particular, unless you were trying to use addressable terminators and you had two different instances, two different terminators using the same identity, then of course you wouldn't get the expected result. But today it would be allowed. It wouldn't be an error. And if someone had stolen my identity somehow, then it would be they could just impersonate me, and it wouldn't be an error.
Yeah, it's been a while since I've looked at it, since it's not something that we that particular piece is something that we're using heavily right now. So might be something to come back and revisit.
Yeah. It'd be useful, even if it was
Um,
just an extra step, just to be able to configure that rigor. Might be useful.
yeah, that's why I made it pluggable, because depending upon because identity is sort of a loose concept, right? You might want different ways to validate that identity for different use cases, right? So yeah.
I don't know what you mean by it's a loose concept. Seems like it's a pretty rigid concept.
Well, it's loose in the sense that identity on Terminator is just a field, right? It's just an arbitrary string. So it may be the same as your edge identity, or it may be something completely different. It could be a phone number, could be an IP address, could be a host name, right? It's kind of up to you how to define those things.
But I mean, we
So
only have one way to specify an identity, right? Like you can't have a host name that is an identity. How do you do that?
But so by the SDK by default, you can tell it use my edge identity as the Terminator identity, but you can also provide an arbitrary value.
I see.
Instead, and we'll use
So
that.
then,
I got you.
okay, so, and this is the field that's populated when I, as the SDK that's going to host the service, contacts the edge router to say, I wish to host the service known by some arbitrary value. That could be a phone number, it could be a host name, or it could be like, if it
Right.
is my identity, then is it like a crypto string, or like the public key, or is there some,
It's
does it
just
have magical,
your identity's name. It's the identity
the
secret
name
that
of the
is worn.
identity? Okay.
Yeah.
So if it's the name of the identity, then is it still just a string, or is it
It's still just a
known
string.
as an identity? Okay.
Yeah.
All
I
right.
think we should. I mean, I think this is an interesting topic, but it's also sort of an undeveloped area. So I think
Okay.
we should wait until to really get into it more until we're actually. There's a lot of interesting stuff coming with VoIP. So I think once we see more development in the area, this will be something to dive further into. And also, I just don't want. I want to get to the the edge router, the tunneler hosted pieces, the router tunneler hosted pieces, program at a time. So I want to look at how we can kind of do all the same stuff that we just did with SDK hosted. I want to look at how we can do it if you're hosting things from a tunneler that's embedded in a router. So if you're doing that, then you're going to be running, right? So for these cases, SDK hosted, our hosting application had the SDK embedded. It was connecting up. It was doing all that stuff on its own. In this case, we still need our server application running, but we're going to be running it as a standalone process that's just going to be expecting connections to come in over TCP. So what we're going to do is we're going to our environment now for that. So we're going to set up our multi-router tunneler hosted. So with the SDK hosted, we have sort of health built into it, right? Health and costs and precedents are all kind of built into the SDK, right? If the SDK becomes unreachable or the SDK application dies, that connection is severed. The edge router notices that and removes the terminator. When the SDK reconnects, it will reestablish its terminator. With the tunneler, right, it's reaching out to the application. So it doesn't have all that context of, is the application alive? Is it healthy? Is it still there? It doesn't know, kind of what state the application is until it tries to reach out and use it. And maybe that at that point, it's too late, right? You kind of want to know something is unhealthy all the time instead of just when you're actually trying to use it, because then it's kind of too late at that point, right? So
Right.
we need to do more in this case so that we get a similar experience. So what we're going to do here is, first we have to create our config, right? The tunneler needs to know where to reach out to. And so that's, we're setting up terminators in our config here. So we're setting up one for each of our endpoints. We still want to have redundancy here, right? We want to have 2 application servers running. We want to have at least 2 routers running. So we still want our 4 terminators. So we don't want to lose any of that redundancy. So each edge router is going to be reaching out to each of the server applications. So we have our addresses here. This one's gonna be running on port 1234, and this one's gonna be running on port 1235. And then we're also going to be adding a health check in here. So we have a port check here. This can be running on a separate port 2234. And this one's gonna be running on port 2235. And it'll be running once a second. And it'll have a timeout of 100 milliseconds. And then we have some actions here that will get run based on the output of those health checks, right? So if the health check fails, we will mark it as unhealthy. If the health check passes, it will get marked as healthy. There's a lot more that you can do here that we're probably not going to dive too deeply into. Just know that in addition to just marking things healthy or unhealthy, you can trigger things based on.
I'd really want to stay away from this right now because I think this is going to open a ball of wax. Like I think that this seems like a whole other ZDTV that we should get to, and we're running slow on time here.
Well, this was kind of the whole point of this ZDTV, but maybe we'll have to do a part 3.
Oh, the health checks was?
Well, yeah, I mean the health checks, and so I mean this is all about, right, how to configure a service for kind of HA environment, right? And this, from a hosting perspective, being able to configure health checks is very important, right?
So the health check determines whether or not the traffic flows to that particular instance.
Yeah. So you can do, maybe we'll do a follow-up on it where we.
Yeah, it just feels like, so like, I can tell you from my perspective, I've never used the health checks still. I work here. And I don't understand them enough. So I'm already you've already gotten me a little bit on my heels because I'm not sure what I'm like. I need to just be able to get my traffic to the HA endpoint first. That'd be step 1. And then if we go into how health checks work after that, that'd be cool, right? Like,
okay, so we could look at this. If you just ignore the port checks for now, right? Then we've just got these 2 sections here where we're saying we got 2 terminators, one going to localhost port 1234 and one going to localhost port 1235. Right. So if we look at our terminators now, you can see that I've got our four terminators. They're all currently failed because the applications aren't running. But we can start them up.
And was that configuration inside the router?
This here?
Yeah, the terminators, all that.
So it's
config. It's a config. I see.
It's a config, yeah. Right. So when we create this Echo host config here, and then when we create the service, we're tying that Echo host config to it. So
gotcha.
This Echo service has this config associated with it. You can have this config. Configs are just there for applications to use. They're just extra data that's associated with a service. So an SDK hosted application could host the Echo service if it had the proper policy, right? And unless it knew about this config type, it would just ignore it. So it's
So now it's starting to come into. I'm getting it a bit more now. I see. So you're creating a service which has 2 endpoints, and then only those endpoints will be available if the action is available, if the health check succeeds. Now I'm getting where you're coming from.
Yeah.
So Paul, the health check directly informs the precedence, and that means this. So it's like mastering that precedence, causing it to be failed, have a value of failed because the health check is failing.
Right. So this config is understood by the tunneler code, right? So the tunneler functionality can live inside the router. It can live standalone. There's the same tunneling implementation is available in the C tunneler and the Go tunneler. So the tunneler application reads this config, and it says, okay, there's 2 terminators, so I'm gonna request these terminators be created on my behalf. And then for each one of these, I'm gonna look at the port checks, and I'm gonna start something that will run this health check for me on a regular basis, right? So once a minute or once a second, it's gonna open up a TCP connection to localhost 2234, and based on what happens there, it's gonna run those actions, right? And those actions in this case are just, if the health check fails, mark it unhealthy, which in this case means whatever the current precedence is, change it to failed. And if the health check starts passing and we say mark healthy, that says take it from failed to whatever it previously was. So if this was previously required, it will go from required to failed, and then once it passes again, it'll go back to required. If it was a default, it'll go from default to failed, and failed back to default again. So
that makes perfect sense, but I don't see it in the config right here where that is what it normally should be, default or required.
So by default, it will be default. We also have, you can also define in here a different precedence, and we'll.
Oh, okay. It's just
we might not have time for that.
I understand. Yeah, go ahead.
So I was going to look at that next. But if we just look at this now, if we start up our, here it suggests how to run these things. So the Echo server also has a health check optionally built in, so that you can run them separately, right? Because otherwise you see a lot of noise, right? If you can health check your primary endpoint, but if you do that, you'll see connection made, connection drop, connection made, connection drop. So this is just makes it a little nicer to look at. So if we run, let's start the first one here. If we now look at our terminators, we'll see that 2 of them are now at default and 2 of them are still at failed. If we do our zcat, we'll see that data is coming in and out here. We can then start our second one. And now if you look at our terminators, now they're both at default. So now they're both healthy. If we stop one of these, the health checks are running up to second, so those are back to failed again. Right, so this gives us that reactivity where we're not relying on trying to use the service to tell if it's failed. Right, we have something that is going out and saying, "Are you healthy? Are you healthy?" And you can either, the health checks aren't super complicated. You kind of want to establish a baseline, because you can, if you've got some very complicated health checking scenario, you can do all this with your own code as well, right? You can write code that does whatever health check you need to do, and then uses the ZD APIs to update precedence and costs on your own too, right?
Right.
If you want full control right in your application, you just do it SDK hosted, right? If you want to have some complicated management for an existing application that you don't or can't put the SDK into, you can have some helper application that runs those health checks and then pushes those settings into ZD as appropriate. But we wanted to provide some baseline set of functionality, right? So you can do these port checks, and you can also do HTTP checks, where you'll hit an HTTP endpoint and look for specific things in the result, or specific response codes. And so you can do things with the triggers, like mark healthy or unhealthy. You can also do things like only mark it unhealthy after it's been failing for 5 seconds or 10 seconds, or if there's been 3 consecutive failures. And you can also increase and decrease cost. So you could do things like, if this is unhealthy, then bump the cost for 10 seconds and then mark it unhealthy. And that kind of thing. And you can also send events in, right? We talked about Terminator events. that you can monitor with your operational systems. You can also generate events from your health checks here that get passed back to the system that you can monitor if you want to have something external doing something with those events. So this is kind of like the baseline for hosting services with the router tunneler. We can also look at the make the config addressable. So here we're doing the same kind of thing where we're explicitly here telling it, what the identity is. So this terminator is associated with EchoHost 1. This one is associated with EchoHost 2. This should have, there we go. So actually I should start, kill one of these, right? Yeah, kill that one. So that one was still failed, this one's default. We now have those identities associated with them. And now we can do the same kind of thing that we were doing before, where we connect to a specific one of those. And we can also do the precedence, so we can update our config HA. So here, instead of using identity, we also have precedence here. So this one is now marked as required. This one is marked as default. And now we have these two required. This one is default. We can connect to.
Got it. So the precedence, the desired precedence is part of the hosting config, host v2.
Yeah. Okay, so that was kind of. There's more to talk about, but we're kind of close to the end here. So maybe I don't know if you want to take some time just to. I know Marcos had some questions.
I just want to say, in general, it is super powerful and fascinating that we're talking about highly configurable, even adapt with some built-in intelligence kind of software-defined HA, and we didn't even need to talk about things like redundant IPs, virtual IPs, CARP, VRRP, like all these ways that exist for achieving high availability. None of that's even in play here. This is all software-defined inside of ZD. It's amazing.
Yeah, I think to a certain extent, if you're hosting your service with ZD, then there's less need for things like load balancers and things like that, because a lot of that is sort of built into ZD. There's certainly probably still some holes where you can't do everything with the health checks. But again, you can, if you have some very specific need, you can generally, the APIs are there where you can build that yourself.
Good comment,
All right.
Marcos.
I think that's
Same.
I think that's a good way to end. All right, Paul. Well, always a great ZDTV. Thanks for stopping in, taking us on a big tour here, and we'll see everybody next time. All right.
Thank you, Paul.